Today we're going to talk about proving triangles similar. When we talked about proving triangles congruent, then we had 4 ways to prove a triangle congruent. We had side, 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 angle, side, angle, side, angle, and angle, angle, side. All of those ways worked to prove triangles were the same, and each piece had to be exactly the same. I needed 3 equal sides, or a side, an angle, and another side that were equal on both triangles. When we're proving triangles similar, also remember the signs for congruent look like that. If we're proving triangles similar, we only use the little squiggle. We don't need the equal sign because we're not proving they're the same. We're proving that they're the same shape but a different size. Well, we only have 3 ways to prove triangles are similar. Angle, angle, side, angle, side, and side, side, side. But this time we're not looking for pieces to be the same. We're looking for the ratios of the sides to be the same. The angles can match. The angles should match. The sides, we want the ratios to match. So we showed how to prove ratios match with the last homework. We take the corresponding sides and set up fractions and reduce those fractions. So let's look at an example of proving triangles similar. Now, just like when we were proving triangles congruent, sometimes we might have to assume some information. So let's say we have triangle STU, triangle EDU. One side's 39, one side's 40, one side 16, and the other side 16. So on this particular shape, we need to assume some information before we can even begin. Right now we just have 2 sides. We have the side of 16, the side that matches it on the other triangle, 40, the side that corresponds to it. We have a side of 16 here, corresponds to the side of 39. So we have a side and another side, but the 3 ways were angle, angle, side, side, or side, side, side. And we only have 2 sides, so that's not enough information. Even if the ratios do match, we need to make sure we have a side, an angle, and a side. So we look at our shape and we know when lines cross each other, then the angles across from each other are equal. Those angles are congruent. So this would be side, angle, side. Now if we're proving congruence, all we need is side, angle, side. But when we're proving similarity, we've got to make sure that our ratios match. So I take the 16 and I put it over its corresponding side. So right now I'm looking at the green, I'm going to put it over 40. Then I look at the other 16 and put it on its over its corresponding side, 39. Now we can reduce these fractions. So we say what divides into both 16 and into 40? Both of those divide by 4. That would give us 4 over 10. That's not even reduced all the way. I didn't pick the biggest number, so I'm going to have to do it a second time. Divide by 2, I get 2 over 5. Now 16 over 39, there's nothing that divides into both of those, so we leave it as 16 over 39. Now these fractions do not match. If they don't match, these 2 triangles are not similar. So let's look at a second example of proving triangles similar. So we have triangle VUT, and given to you is that this angle we're going to put 2 marks, this angle we're going to put 1 mark. And then let's say we have triangle JKL. J has 1 mark, K has 2 marks. This time we don't need to set up any ratios because we have angles. Now all we need is 2 angles to be the same. If any 2 angles are the same, the third one's automatically going to be the same because they have to add up to 180. So we have 2 angles the same. That was enough to say these 2 triangles are similar. So if you recall, we had to write our triangle congruence statement. Now we have to write our triangle similarity statement. Triangle VUT is not congruent, sorry, similar. Let me erase that. I should have used the similar symbol, not the congruent symbol, because we're not proving they're exactly the same. We're proving they're the same shape, but a different size. So triangle VUT is similar to, and then we have to go in the same order. V had no angle at all here, so we start with L. U had the 2 angle marks, so we'd have to go K, J. And then we have to say why they are similar by angle, angle. So we can now prove triangles are similar. If it was a side, 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 we'd have to prove that all 3 side ratios are the same. We can also again find missing side lengths or solve for x. When we're doing that, now we're going to start throwing some different shapes at you that'll make it a little harder to decide what goes over what. So I'm going to draw a triangle that looks like it's one shape, but really it's 2 separate triangles. When we draw a shape like this, then there's this inside triangle that's a little bit smaller, and then the outside triangle, which is the entire outside shape. So when we have this set up, these are similar triangles. We already know that these are similar. We know they're the same triangle, but different shapes. Sorry, different sizes. Same shape, different sizes. So we know we can set up a proportion. But we have to decide what corresponds with what. So we know we have to pick the letter X. It's got to be used. So looking at the letter X, it's the side of the purple triangle. That's kind of on the bottom left side. It looks like a hypotenuse almost to me. Well, that means that's going to correspond to the hypotenuse of the big yellow triangle, which is 22. So we put the corresponding sides lined up together. We stack them on top of each other. Now we picked X, and that was from the smaller triangle, which means I've got to pick a number from the smaller purple triangle. I could use 6, I could use 9. Doesn't matter, I can pick either. I'm going to pick 9. And I picked 9 on purpose because this is one of the things that could happen where it's a little harder to tell, well, what am I going to use next? Well, if I use 9, I've got to use the entire length of the yellow triangle. This entire corresponding side. So if I'm going to use that entire corresponding side, I need to add those two numbers together and get that this entire length is 18. Once we have our proportions set up, we learned yesterday when we solved proportions, we cross multiply. Sorry about the squeaking, I'm doing this recording at home today. That was my dog chewing on this toy. So we cross multiply. 18 times x is 18x. 22 times 9 is 198. And then we divide both sides by 18 to solve for x. And we get x equals 11. One last example and we'll be done with notes for today. So let's, as we always do with our examples, they get a little harder each time. We're still going to find x. We know the triangles in the picture are similar, but again, we're going to take one of those pictures where it's a little harder to tell what do we use to set up our equation. And they also give us extra information. We don't necessarily need every single one of these numbers. So again, we have to imagine our inside triangle and our outside triangle. I draw it in color because it's a little easier to see. So we must pick our x values to be part of our proportion. We know we're going to have two fractions. We must pick the -4 plus 4x. So that means I need to pick the corresponding side of the other triangle. The -4 plus 4x is just for the smaller purple triangle. The corresponding side would be that same top side, but on the yellow triangle, which is 64. We can line it up underneath, or if you wanted to line it up across on the top, you can. You just can never line it up diagonally. So I usually line it up underneath. -4 plus 4x over 64. Now we must pick something from the small triangle. I either have 27 left or 36 left. It doesn't matter which one we pick, as long as we then pick the corresponding side. So I'm going to pick 27. Corresponding to that is 72. Again, we cross multiply and solve. This equation will be a little bit more difficult to solve because we're going to have some more opposite operations to do. So we multiply 72 times 4, -288. Now that 72 has to multiply by both of those. So 72 times -4 is -288. 72 times 4x is positive 288x. And then we cross multiply the other way. 64 times 27 is 1,728. It's okay that we're getting big numbers because when we divide it at the end, it'll get back to a smaller number that we're used to working with. So now we do opposites. We do our opposite operations. We have to think, what's our first opposite? So opposite of minusing is adding. We have to add 288 to both sides. $1,728 plus 288 is 2016. Oops, sorry, I didn't mean to make the page go down like that. So again, that's 2016. Then we do our final opposite to get rid of 288. We divide by 288. 288 divided by 288 is 1x, but we don't have to write the 1 in. 2016 divided by 288 is 7. Don't forget we have a quiz next time. And I will see you guys on Wednesday.